Good afternoon or morning, whenever you're watching this. This is Mr. Haney. I told you guys I'm going to be making some videos to talk about what I've been teaching the students, because you and I did not learn math the way that I am teaching it now. So just kind of try to keep us all on the same page. I will be making these short videos. Let's go ahead and get to it. So we are talking about place value at the beginning of the year. We all know about place value, but I will go over how I've been teaching it, what I've been talking to the students about, so that you guys can help reinforce it at home. Let's go ahead and get right to it. So we started off, we got some calculators out, which they're not supposed to use in fourth grade for testing, but I like to use them just for this illustration. Right now I've turned on the calculator, and all we see is a 0. I think you can see that on the screen just fine. There's a 0, and it is just in one spot. So I had them add +1 to 0 and equals. We have 1. I made sure to point out that the 1 is not to the left or the right of where the 0 was. It's in the same exact spot where the 0 was. So we press equal again, and that sends the same program of adding +1, and we get 2. Now we have 2. It's in the same spot. Then 3, same spot, 4, 5, 6, 7, 8, and 9. All of the numbers, we'll call it for now, all the numbers that we've seen on the screen so far have all been in the same spot. And if we notice, we also have those same numbers on this calculator. If I press equals again, I'm going to add +1 to 9. We now have 10, which all of us know this. This is easy stuff. You're probably thinking this is not high enough math to be fourth grade, but it's important that we build these foundations before we get into the big numbers. So when I added 1 to 9, we realized that all of these digits, they're called digits. I called them numbers a moment ago, but we're going to refer to them as digits. So I had them write down digits. All of these digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, those are the only numbers that we're going to use to make any number we ever work with. Even up to the millions, even up to the billions, trillions, and so on to infinity. We're only going to use 0 through 9. We only have to worry up to the millions for fourth grade, so that's all we'll cover. But just wanted them to know that. So we've made it to 10, but now the thing to notice is that we no longer have just this space where we had 0 through 9. We now have another space that's been added, and we're using the 1 again, but it's now in this new space, so it has a new value. It is now 10 times as much as it was its value is now 10 times as much as it was when it was only over here. And then so we learned that this is the ones place, that where we had all the digits. We can put 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9 in this box, and it will only mean that number itself. So 3 is 3, 4 is 4, 5 is 5, and so on. But as soon as we put a digit in this box, wow. Nice drawing, Mr. Haney. As soon as we put a digit over here to the left, it is now 10 times bigger than what it would be here. So a 1 in this space just counts for 1 of some object. A 1 in this space counts for 10 times 1, because this space here is 10 times greater than here. We demonstrated that today using base 10 blocks. You may or may not have used these before, but they're little manipulatives. And this little cube here stands for just 1. It is 1 something. It could be ice cream, it could be puppy dogs, it could be water bottles, whatever you want it to be. We're unfocused. Anyway, it can be whatever you want it to be, but it stands for 1 of that thing. So if you have 2, that's 2 things. 3, 4. So if I have 4 of these, that's just 4. Now, we have some other blocks that are larger, but they coincide in size with these blocks. And I asked the students to use their small blocks to make a block that looked exactly like the longer block that I handed them. So they got their blocks until they could make a stick like that. And we keep going, keep going, keep going. It's not quite as long yet. And we still need a couple more. They grab them. And so now we have a stick that looks just like this other one. I had them tell me how many they took to do that, and they could tell me it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we call this a 10 block. or a stick of 10, sometimes I'll call it. But they should know that it takes 10 ones to make 1 10. Again, this should be just review. They should know this before 4th grade, but some people, we need them to be on the same page, and then others that know it, it never hurts to review the basics. So 10 ones equals 1 10, and the same thing goes for when we write it abstractly as symbols. 1. 1 goes here, that would be just 1 block. And then if we write a 1 here, that 1 actually represents this. It's 10 ones, but it makes 1 stick of 10. So we call this our ones place, and this is our tens place. So if I have a 1 in here, once again, this is 1. It only counts for 1. If there's a 5 here, it's just 5. But if there is a 1 here, it's 10 times 1, which is 10. If we have a 5 here, it's 5 times 10, which is 50. But I told them today, if you go to Walmart and you are going to buy your favorite video game, and you've played it before, you know it's a good game, and you see something that says this, you're gonna say, wow, I am absolutely buying that video game. Because that's $7, and they normally cost like 30, 40, 50, 60, 70 bucks probably. So that's a good deal. Well, you take it to the cashier, and they tell you that'll be $70. And you look at them and say, excuse me, what? It says $7. And they say, no, that's in the tens place. You can't do that. We don't know what place that's in, so we have to put a 0 to hold the place to show that the 7 is in the tens place, not in the ones place. If you see this, it's just a 7. If you have a 7 with a 0 behind it, we have shifted the 7 to the place value to the left, and we have 70, not 7. So we continued that on with our calculator, back to the calculator. We had 10. After I had them count 1 through 10 and get the second place value, I had them add 10 to 10. And we start counting by 10. So you'll notice we had 1, 2, 3, 4, 5, 6, 7, 8, 9 over here in the ones place. Now in the tens place, the same thing is going to happen. We have 2, 3, 4, 5, 6, 7, and so on. We're using the same digits, but now it's 10 times as much because it's in the tens place. So we make it to 90. That's as high as you can go in the tens place as well with the nines. Of course, you could always put 1, 2, 3, 4, 5, 6, 7, 8, 9 in the ones place, and you can go all the way up to 99, but that would be the greatest number we could make using only these two place values. If you want anything greater, if we add 1 to 99, let's just add 1 until we get to 99, and we have 99. If we add 1, we see that we now have a third place for our place value. And the students can always tell me this is 100, which is good because they're in 4th grade. They should be able to do that. You should be proud of them. We have 100, but we have gone back to 1. And if we start noticing the pattern, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is all that we can put in this space. We can't fit 1 and 2 in here. We can't have 1 and 2 or 3 or 4 or 5 and 7 or any. We can't have more than 1 digit in each place because each place tells us the value of the digit that is in that place. So if this is the ones place, whatever number is in there or whatever digit is in there, that's it. It's times 1. 7 times 1 is just 7. If we have a 7 here, that's 7 times 10, which is 70, which you have to put a 0 here to make that true. If there's a 7 in this place, because it is the hundreds place, it's not just representing a 7, but rather 7 times 100, which gives us 700. And we keep going on like this, and you'll notice as we go, the tens place is 10 times greater than 1 because it takes 10 of these to make 1 of these. If we continue that going, if I take 10 blocks, 5, 6, 7, 8, if I take 10 groups of 10 and put them together, that is 100, a total of 100. And we also have some 100s blocks. And so I have them compare these to the 10 tens, and we see that it makes the same size. It equals the same size. So this is 100 ones, it's 10 tens, and it's 1 100. We can keep that going. If I have 10 of these 100s blocks, okay, I can also compare that to a 1000s block and see that they're the same size. I'm kind of running out of space here. Let's see if I can. So if I lift this up, you can see that those 10 blocks, 10 100s blocks are the same as this 1 1000s block. I don't have any blocks greater than that, but I try to get the students to imagine that if we kept going, we could do 10 of these, and it would look kind of like a really, really big version of one of these. It might be about the size of a couple baseball bats stacked together, thicker, of course. And then if we took 10 of those, we would have a really, really big one of these, about the size of, a rug. And if we took 10 of those, we'd have another one of these that would be almost the size of a room. And so obviously I don't have blocks to do that. But we want them not only to know how to write numbers, but we also want them to understand the value of those numbers. So once again, if there's a 7 here, it's not just a 7, it's 700. And we have to have 700. So we keep going, and we have a whole new set of these numbers as we go on. 100 plus 100 gives us 200 and 300, 4, 5, 6, 7, 8. All of this is very tedious, but it's for a purpose. Once we get to 900, if we add another 100, we're now to another place value. So we have 1,000. And so you get your thousands place. You continue to do that. 1,000 plus 1,000, 10 times gives you 10,000. Once you get to 10,000, you do 10,000 10 times, you get 100,000. And then 100,000 10 times becomes 1 million. And then we have covered all of the place values that we're going to be doing in 4th grade. As we move on, we're going to be using these 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And depending on the way that we order these in these boxes, we'll get a different number. So we have our thousands place. I'm just going to abbreviate thousands, 10 thousands, 100 thousands, and millions. But once we get to this point, we want to start to recognize that not only is there a pattern of times 10 to the left each time, it gets greater by 10. Not only do we want to realize that 110 is 10 times greater than 1, 10 tens is 100, meaning 100 is 10 times greater than 10. And times 10 times 10. Not only do we want them to realize that, I have no clue where I was going with that. I apologize. But we do want them to see that. Give me a moment. Yep, nope, I'm done pausing for that, so we're going to move on. We also want them to think about, when we start writing numbers like this, we're not going to be using the place value chart. We're just going to write them. So if you want the number 2,367,844, if you just look at that, and even I'm used to putting spaces here, so I accidentally put spaces, but if you just have these numbers grouped together into a cluster, it's kind of hard to tell what it is. That could be 2 million, not really sure. So you have to come back and you have to count the place value. So we use commas in between each of these areas of 3. Oh, that's where I was going. Okay, see, I knew it would come to me. Not only do we want to notice the times 10, times 10, times 10 all the way, we also want to notice this pattern of ones, tens, hundreds, and then this is 1,000, 10,000, 100,000, and then 1 million, and if we kept going, it'd be 10 million, 100 million, and then 1 billion, and so on. We want to notice this 1, 10, 100, 1, 10, 100, 1, 10, 100. And we'll be talking about how each of these areas is known as a place value period, a group of 3, and it's just ones, tens, hundreds. So this is the ones period. All of these are just multiplied by itself. So there's ones, tens, hundreds. Here we have the ones, but they're multiplied by 1,000. The tens are multiplied by 1,000. The hundreds are multiplied by 1,000. So this is the thousands period. And if we kept going, we'd have the millions period and the billions period and so on. I believe that is all we talked about this week. Next week we will be continuing with this, and we will start to compare and order multi-digit numbers by placing numbers or digits into each of these place values, and I will make a video for that next week. If you have any questions, feel free to message me through Class Dojo or through School Status or an email. Any of those will be just fine. Thank you for helping your students or your children by watching these videos yourself and maybe using them to review with your kids. Have a good week.